right, thank you so much. I'm glad to be here to present some of our activities in ROBOTDALEN in Sweden. Just a few words about who we are. We are an active non-profit organization between academic world, society and industry, financed by the Swedish government, local governments and the European Union. And why Västerås, Sweden? Because it all started in 1974. When the first industrial robot based on electrical actuators came from our city and vastly spread to the rest of the world. And actually, just for you to know that this robot on picture is still working in the factory, which is quite amazing. So here's some movie showing a little bit about what we do.
GroundBot, a spherical robot equipped with cameras and sensors for surveillance of primarily large areas such as airports and harbours. Malta, autonomous trucks interacting with manned trucks, developed to function in industrial environments. IBA 2009, robotized ice blasting for environmental and cost-efficient cleaning of containers using dry ice pellets. Electric roads, development of a robot arm connecting large vehicles on major roads to contact wires so they can drive on electric energy instead of combustion engines. Navigation systems for automated loaders. Navigation systems that make it possible for a 30-ton mining machine to move on its own without external monitoring or steering assistance. All 4E HAM, autonomous wheel loaders developed for efficient material handling in a plant for asphalt production. Sense Active. The bin-picking solution guides a robot to pick unsorted parts through shape recognition. Rosio. With robotized friction stir welding, surfaces are welded together by heat, generated from the friction of a rotating tool. CompoGrip. Specially designed grippers made of lightweight composite material, enabling quick reconfiguration for new objects in the production. Opiflex, a robot platform that can move between production cells, performing different tasks, thus enabling SMEs to invest in flexible robot automation. Robot Colleague. Solutions for easier and more efficient programming of robots using speech and gestures. Zoom Uphill. The all-terrain, electrically powered four-wheeler gives people with difficulty to walk access to the woods and countryside. Bestick. The eating assistance device for individuals who can't fully use their arms or hands makes it possible for them to still eat on their own. Giraffe. The remote-controlled mobile robot equipped with a camera and monitor provides remote assistance and security for the elderly in their own homes. Trainee Test. An exercise machine equipped with robot technology that produces variable resistance and the possibility to optimize and measure rehabilitation. RobCab. The autonomous mobile robot relieves hospital staff from in-house transports, giving them more time to care for their patients. Remain seated. A seat for sailboats that allows disabled sailors to sit upright, regardless of how the boat leaves.
as you saw at the movie, there's plenty of different applications and fields of expertise. And some of the products you can actually see in our booth here at the show. So we work with three main areas. Of course, industrial robotics, since our heritage of industrial robots. Field robotics is where robots go that people don't want to go. And health robotics, which we call today technologies for independent life. And that's the area I will focus on talking about today. We are, of course, addressing the challenge of aging society. I'm not sure if you've seen this number, but this is a graph showing number of people, working people, aged 20 to 64, and contra people being supported. So today, on the left, and 2050 on the right. So the average number for OECD countries is 4.2 today, and that will change to 2.1. Japan will have 1.2. So we'll see a drastic change in society. This is the same kind of numbers, but showing more on a time scale. So you see all the countries are moving the same way. And when I talk to people, care professionals, they say, so why do we need technology? We're talking about elderly. But technology, as we see in the previous presentation, can actually help us. And it has helped us before when you had challenges. So, for instance, when the animal became too big, we found a nice way to kill it. And if something went too heavy, we would develop the wheel and so on. And I think in the future, the technology, especially robotic technology, could help us, as we saw in the previous presentation. And I think that we shouldn't maybe focus so much on robots. We should focus on developing technology, robotic technology that helps people. Because robots have some problems in the care industry. One is, of course, attitude. There is a recent study done in Europe, and some of the question was asked for the public. And one was, do you think that robotics should be used in elderly care? 4% said yes. So we asked another question, do you think that robots should be banned from using elderly care? And surprise, surprise, 60% said yes, it should be banned. So there is some challenges we need to overcome. And why is that? First of all, there are different views on robotic technology. If we talk to researchers, they see, of course, great benefit for humanity. When we talk to, if we go to Japan, I mean, we have a different story. We have robots are heroes. And if you ask Europeans what a robot is, they'll say that this is the robot. So there's an image problem for robotics, especially in Europe. And the US as well in some way. And of course, Hollywood has not always been helpful. I'm not sure if you've seen this movie before, but it's a very early eating aid from Charlie Chaplin time. And it shows how robots could help humanity. Something go wrong. Show the whole movie. It's actually worth seeing. And why is that? I mean, if you look at industrial robots, for instance, they were very fastly accepted into the industry. But it was built by engineers for engineers. So we could see the benefit. We could see dirty environments becoming, you know, very structured, cleaned environments. But for the caregivers, we have a robotic technology targeted to people that actually moved away from technology in their career path. So it's very hard for them to accept that elderly care and healthcare could be helped by robotics or technology. But they agree on one thing, is that if you say that robots cannot and should not take care of people, but rather help us to stay independent, as the technology in previous presentation, and take care of each other, then we don't have a problem. So communication is very important when we talk to elderly care environment. I'll show you some examples from ROBOTDALEN developed here and commercialized. Because we hear stories all the time that it's very hard to put robots in the elderly care market. And it is, but there are ways to do it. Some examples is BESTIQ, which is an assistive eating device. We can actually show it in a demo in the booth. You can eat by yourself if you have some problems in your arms. It can be controlled by, by basically any input device. So I'm going ahead here. Here you go. So the interesting part is that it is developed by a person with post-polio, and his dream was to be able to sit opposite his wife and in a restaurant and eat instead of being fed. And Robin is 9 years old, and he's going to a regular school, but he hated lunches previously because he was taken away to a separate room and being fed by his assistant. And nowadays with BESTIQ, he's the king of the cantina, because every kid wants BESTIQ, of course. So it changed lives in a way, of course. It's more and more used for elderly care, people with tremors, for instance, and other disabilities. A RobCab, a typical application where we can see how robotic technology can help us, because we have lack of resources in Sweden only. In 20 years, 30% of our workforce in elderly care will be retired. So we have kind of a problem. Nobody wants to work in elderly care and healthcare. But in a normal Swedish hospital with 500 beds, there are 25 nurses doing nothing else than fetching things. And this robot can actually free those nurses to do what they should do, to take care of people. It can pull trolleys, it can help pulling beds, it can of course independently go and find its way and interact with the elevators and stuff. This is another interesting product that is developed by a person whose wife has MS disease, and she loved to be out in the nature. And she couldn't, it was rough. So he developed it for her, and now they can actually go anywhere. On the beach, to the woods. And it's on the market as well. You can ask yourself, why is robotics? Well, there are sensors in there adjusting the wheels and suspension, so it can go upright, so to say. I can tell you myself, it's extremely fun. So training test, you heard in the movie, it's a training and testing device that is being used now by Italian Football League, and now we're talking to large ice hockey teams in US, like Dallas Stars, for instance. What it does is that it replaces weights with very advanced motion control, and we can actually simulate 1G 100%. You can imagine if you do rehabilitation, you do often work with very light weights and high speed. And that's not possible with normal weights. Okay, so the next project is remote stroke rehabilitation. We know in Sweden we are very good at acute stage rehabilitation of stroke, but we have very big problems with long distances to be able to rehabilitate people. So we're using very common technology, normal TV and the normal Kinect, Microsoft Kinect technology, to be able to rehabilitate people in their homes. And this is a SEM glove is a glove that I'm actually wearing right now, and it's a glove that strengthens your grip. If you have some weak grip, you can actually try it in a booth as well, if you come to us later. Very interesting, simple project. Cyberdyne is a Japanese product that we help to put on the market in Europe and do clinical evaluations with Karolinska Institute. Giraffe you may be seen before. It's a telepresence device that helps people to feel confident in the home and stay home longer. It's actually used in real life today. And it's not so much the hardware, it's the implementation of the technology that has been the hard part. But it's been using in Västerås city for a while now, and it's spreading now to the rest of Sweden. If you want to know about this, more about this, we can talk about it later. I'm a little short of time, so I need to hurry up. Okay. So what we've done in Sweden is that we created this real-life test bed. It's not a demo environment like an apartment with the gadgets. It's real organizations with both public and private caregivers, real users and user groups, and we can provide real-time feedback to developers, and also in many cases the first clients. And we found out that the technology is actually only the small part. It's when you apply this in real life, you see that all these policies, work process, laws, attitudes, training, that's the big part. That's the big challenge we have to overcome, and that we can help with. Of course, we have an innovation process. I'm not going to go through all of this, but we have our own money. We spend roughly €3 million per year in different projects. We can also tap into other money from both Nordic and EU funds, which could be useful. One example is, for instance, the Excite project that generated €3 million from EU. And a new project just came out called Silver. I encourage you to check it out. It's a pre-commercial procurement application where you can actually see what kind of solutions the caregivers are looking for and suggest the robotic technology to solve it, and then go forward. It's €2.15 million and it could be applied today. We've been mentioned in OECD report about one of the clusters in the world that actually been able to put this kind of technology on the market quite successfully. But we have 4 simple goals. Maybe not so simple, but we want to make our citizens independent, and we don't want to call it robots. We need technology to do that. We need to help our elderly and disabled to be and continue to be active members of society, and to provide care more efficiently. And of course, to create sustainable growth in Sweden. That's our goal. So we work, what we can offer is all the strengths that Sweden has with Swedish care knowledge and innovation processes and ethics and so on. We are the most efficient test bed to test in real life and evaluate and implement technology. So what we've done, for instance, from Japanese cases, we can move technologies to Sweden, we can brand them, and then they are ready for the whole Europe. We can also finance this kind of tests and implementation projects. We also work with large US organizations like Ascension Group in US that are very interested in using technologies that is proven already. So kind of in a way we kind of open ways even to the US market. All right, thank you for listening. If you have some more questions, please come to the booth.
Thanks a lot for this presentation that stresses out how important is the involvement of user and the importance of evaluation. Do you have any question to Mr. Hagman about this talk about elderly? No? Yes, one? Okay.
A question about Cyberdyne's product, for example, how Swedish government reimburse this device, which must be very costly.
You're talking about Cyberdyne product?
For example, that
yes,
you said you're going to distribute in Europe.
Yes, as you know, in Sweden, all the care is paid by the government. All healthcare system, everything care is paid by tax money. So the healthcare is free. So what we do is kind of implement good technology so we can see that it's beneficial for the users and the organization. So we can save money and add value for the users. And then it's kind of paid by the government.
Right. But health cost is so expensive for all European or even Japanese.
Yes.
And unless the government has strong policy of refunding, it's very difficult to get to approve
it's
the
very
difference
hard
between the traditional and the robotics. Is it worth for the government?
Yes,
to
it
pay
is.
the extra?
All of the projects we done very thorough economical studies as well. So we not only talking about saving money, we're talking about quality of life issues. How a prosthetic limb like Hugh's here talking about, how that affects a person's life, maybe continue to work for another 20 years or these kind of things.
Yeah, so much of robotic technology that's designed well can actually reduce healthcare payout across the individual's life. So even though per unit cost is higher, you save an enormous amount of money across the lifetime of the patient. Because you don't have secondary disabilities, you've increased quality of life, the person can work longer, pay taxes. So it's actually a savings to society.
Yes. We have been able to prove that in many economical studies.
Okay.
Okay.